guys, welcome back. Today I'm going to show you how to solve quadratic equations by graphing method. So the first thing we have to recall is what's a quadratic function. In standard form, a quadratic function can be written as fx equals to y equals to ax squared plus bx plus c, where a cannot be 0. Because if a is 0, this turns into a linear equation or linear function. Now, this is how you write the quadratic function, fx or y. A quadratic equation is, in standard form, is pretty much the same thing as quadratic function, except that y equals to 0 or fx equals to 0. So if y is 0, the quadratic function becomes a quadratic equation. And remember that if y is 0, when you graph it, it's going to give us the x-intercepts. So basically, the solutions to quadratic equations may have either two solutions, one solution or one real solution, or no real solution. So these are the two solutions, or two x-intercepts, or two zeros, or two roots for this kind of a graph of a quadratic equation. If the graph of a quadratic equation is like this, then we will have one unique solution. In this case, there are no real solutions. The roots are complex numbers, but there is no real solution. So complex numbers, you study them in Algebra 2. So keep this in mind, that a quadratic function is y equals to ax squared plus bx plus c. Quadratic equation, on the other hand side, is when y is 0. All right. Now let's solve this question. X squared minus 6x equals to negative 9. The very first thing we're going to do to this equation is we're going to rewrite this in standard form. So you basically going to add 9 on both sides. Now this thing is same thing as the quadratic function. So we're going to graph this part first. So basically, quadratic function is x squared minus 6x plus 9. So let's graph this quadratic function. Comparing this with the standard form, here is the standard form of quadratic equation. As you can see, a is the coefficient of x squared, it is 1. B is the coefficient of x, it is negative 6. C is a constant, it's 9. Now the first step is, we want to figure out if the graph opens up or down. Since the value of a is positive, the graph opens up. Like this. The next step is find the equation for the axis of symmetry. Last time I told you the formula for finding the equation of axis of symmetry is x equals to negative b over 2a. Now substitute these values for b and a right here, and we're going to get the equation. So remember, whenever you substitute the values, the substitution must be inside parentheses. So there is negative of negative b, negative of b, and b is negative 6. So put it inside parentheses. Twice of a. So x equals to 3 is the equation of axis symmetry. This is the axis symmetry. As you can see, that axis symmetry also passes through the vertex of the graph. So let's find out the coordinates of the vertex. The x-coordinate of the vertex has same formula as the equation of axis symmetry. So this formula is same as the axis symmetry, and the result is also going to be same. To find the y-coordinate, we're going to plug x equals to 3 in this function. fx, or same thing as y. So y equals to 3 square minus 6 times 3 plus 9. 3 square is 9, 6 times 3 is 18 plus 9. Now 9 minus 18, that's negative 9 plus 9, that's 0. So y equals to 0. So the vertex for this graph of this equation is going to be at 3, 0. We know that this graph of this function is going to open up, and the equation for axis symmetry is at x equals to 3, and the vertex is at 3, 0. We also would like to find out the y-intercept for this function. So at y-intercept, x equals to 0. So put x equals to 0 in this function, this function. As you can see, 0 squared is 0, minus 0, plus 9. Basically, the y-intercept is at whatever is the value of c in this function. So let's start plotting this graph, and if we need more points, we're going to create a table. So we do know that the graph opens up, and the equation for axis symmetry is x equals to 3. Let's plot this equation, x equals to 3. The vertex of this graph is located at 3, 0. It is this location, 3, 0. This is the vertex. The graph opens up, so the graph is going to be like this. And we also know that the y-intercept is located at y equals to 9. It's right here. Since this x equals to 3 is the axis symmetry, or the line of symmetry, the corresponding point on the other side, since this is 3 units away, will also be here, 3 units away. This acts like a mirror image. We got 3 points, and that's enough to plot this graph. So let's just draw a smooth curve that passes through these points. So how many solutions to this equation? There is only one solution, one unique solution, because this graph touches the x-axis at one point. So what is that solution? X equals to 3. So there is only one unique solution. Thank you.